So what we are using is the g.HISYS, and when you double click the icon, you will have all the channels. So over here I have only 80. So I will assume on the second input port is subject B, on the first one is A. I have only used notch filter. I could actually omitted it. So the less filtering, the better it is for the recording. Over here in the model and the video that I sent you, there is no recording file, so you would basically record it to file. And you can use G to file. And one of the advantages of using to file is that you can actually add the patient data and write whatever you want here. Let's put style always usual subject. And you can also put other data, whatever it is. If you have the ID number, you need a unbuffer and data type conversion, so you could use the other blocks. Since we have two subjects, we need this selector. So basically, you would be using the selector routing. So over here, you see there are a bit more on the pictures, more items. And why? That is because over here it's defined as a port size of 3. Just as in illustration, you could have it like this as well. But what we have used is actually is the 2 ECGs for 2 subjects. So for the first one, you would define it as 1, just like here, and for second one as the 2. So for B, it will be 2. And then before showing the signal, we do apply some filter. The signal will be noise, especially as I use it on myself. I operated myself, so there was a lot of movement involved. And for the adults, you can actually use up to 25 hertz. I think it's in 35 hertz for the pediatric cardiography. You need to remember your sampling rate. So I use 512. You can use any one you want, depending on the signal. So for ECG, probably 512 is a bit exaggeration, but nevertheless, that is one that I use the amplifier. So you have to have this value matching one that was given into the amplifier settings. So you can see it over here. It has to be the same one for all items. Then you usually use the scope for everything you want. If you use the G scope, it has a bit more features. You know, it has the auto calibration. You can change a time base easily, the amplitude as well. You could, for instance, it's not the case here, but if you have the EEG signals, you can arrange them for the EEPs as a head layout. Then this is the block from the RT analyze. So if you put HRV, then you get this HRV from the RT analyze. And it gives you several values. So the problem with using heart rate variability value is that it has 1 minute interval of measurement. So it's not easy to work with 1 minute. It's not so immediate as this this one, beat to beat heart rate. That is the one that we are using. This mean heart rate is calculated for this interval, which is 1 minute. Again, when you are putting this block into the model, then you have to select the correct sampling rate. And also there are some other conditions that you can adjust. So this was just an illustration, so we will take it off. And as you see, I'm showing the heart rate beat to beat values, and those are the ones that I'm actually using for the calculation. And basically what I do, I divide two of them and then compare it, and then subtract it from the value of 1. So it can be positive or negative. Hence, there is this absolute value block, and then I can use any given constant value as a comparison to it. So if I want 2%, then I use 0.02. If I want 5, I use 0.05, and so on and so forth. And the end, I am having that value. So if over here is if over here is 0.01, over here will be 1. If over here is 0.07, over here will be 0. And then there is another part that is not much visible, which is the part of the image. So basically over here we have condition image. I can illustrate you if you put over here in the library, search for image. One of the things that do appear is this multi-state image. And in case of this one, since we have only two values, when the heart rate of subjects A and B is inside certain condition, it will be 1, then we have a smiley. If not, we have this angry or dissatisfied face. And you can also notice this compared to constant 1 value here, and that is linked to that constant. So this one, and you can see this Wi-Fi signal that is linked to this subsystem. Why did I use this subsystem? Well, I use it because this way I can actually open it in the new window. So you can have two monitors, and you can show this to the monitor which is in front of the subject, and you would have your primary monitor where you would be seeing all these values. As an addition, I included these gauges for the subject A and for the subject B, so they would have eventually some feedback. You can also put the value with a new display block, which is now in the development, will be released very soon. If you want to see the values, but this is good enough. You can obviously delineate these values with an error, but I use 60 for 120 because it would fit most of the situations. And then you can have this interval in 10 or 5 or more. If you put too small interval, then you will have to resize it, to resize the gauge to a bit larger image. And that is essentially the entire model. I then perhaps approach this display. So displays just a display from the MATLAB, and it will display any value. If you're making a bit more complicated or more complex models, then I always like to describe every one of them better. So I could put here subject A and subject B. I didn't. But over here we have heartbeat A, heartbeat B, selector A, selector B. So you can follow it, and the markings are pretty consistent. And also when you open this data scope, then you will have also the indication that it belongs to subject B, and very similarly for the subject A. When you are looking down, then you always know who is who. That's a good practice, basically, to 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 include certain description to the, especially scopes. If you have more than one, if you have a single scope, it doesn't matter really, but you can have multiple ones, and then it's not the easiest to orientate through the especially complex models. Looks great.
Yeah, I think so.